In this lecture, we will study about securing email. Okay, so emails, as you know, are used for sending messages, letters. Okay, so here in this example, Alice wants to send a confidential email to Bob. Okay, so she wants to send some confidential love letter to Bob. And confidential means it's top secret. It should not be known to anyone else. Okay, not even her friends, parents, no one. Only she wants to tell it to Bob. So she wants a top secret confidential email. So how will she do? So she needs to ask a network security guy for that. Okay, what security protocol she should use. Okay, public key encryption and so on. So what happens is that she comes and she studies book of Kuros. Okay, and she finds that, okay, when I have to send a confidential email, what do I need to do? And she sees this diagram. So what happens here, to understand this, how we can send a confidential email, you need to know about secret symmetric key encryption and public key encryption. And what are those? So symmetric key is where you encrypt the message, okay, using the same key as you do the decryption. Okay, so the same key is used for both encryption and decryption. So here Alice and Bob should share the secret key. But in public key encryption or asymmetric key, so you lock the message or encrypt the message with some different key and you decrypt it using some different key. Okay, so this is the way out. Now let's try to understand what is it saying. So I want my message email M to be confidential. KS is my symmetric key which is shared between Alice and Bob, and in fact Alice sends this KS symmetric key to Bob, and she also has her public key and private key. Okay, so let's try to see what happens. So Bob has his private key as KB minus and his public key as KB plus. So public key is used for encrypting and KB minus, the private key, is used by Bob for decryption. So message M is there. Now Alice encrypts it with the symmetric key, so KSM. So this message is now encrypted, so it becomes confidential because you cannot read it. So I love you. Okay, this message will look something like hash question mark underscore exclamation ABX. Okay, so you cannot find out that, okay, what Alice has written. So KSM is there. So this is encrypted by the shared symmetric key, but at the same time this secret key, shared secret key, is now not with Bob. And why she wants to encrypt this with the shared secret key is because it's much cheaper computationally to use a symmetric key. So this large message, the large love letter, has been encrypted with the shared secret key, which is much cheaper computationally, and then she uses the public key of Bob, okay, to encrypt the shared secret key by which she has encrypted this message. And now she sends KB plus the encrypted secret key, symmetric key, and the message encrypted with the shared secret key, the symmetric secret key. Now what happens? It comes to Bob. So this KB plus KS, he first need to find the symmetric shared key. So for that he uses his private key to, so KB minus, so this private key he uses to find the symmetric key. So he gets the symmetric key from this process by applying his private key to open the secret key KS. Now he uses KS of KSM, so he gets the message, and this was secret. Okay, so This way there was a secure email, and our aim was confidentiality, which was like successful. Okay, so this is there. So we talked about symmetric key, asymmetric key, and how so Bob finds the message. He uses the private key of Bob to decrypt the symmetric key, and using that symmetric key he finds the message. So simple. But now you might have more requirement. I want, or in fact Bob wants, that it's not another lady known as Trudy who might be faking as Alice and she might be writing something. Okay, so he wants authentication, that okay, is this love letter from Alice or is it Trudy who is faking as Alice? Okay, so he wants sender authentication. Okay, that okay, I'm sure that okay, you are Alice who is writing. And he also wants, because he had heard about man in middle attack, where someone, I sent you the message, Alice sent I love you, and Trudy, the attacker, or the woman in middle, she just adds one more line. Okay, I don't love you. So the whole meaning changes. So he wants message integrity. So whatever Alice has written, he wants that should reach Bob. So now what should be done? So his two requirements were message integrity. It should be the same message that was sent by Bob. There has been no modification, and sender authentication. He's a guy, he is not very much caring about if anyone else reads it. So confidentiality he doesn't require, but he requires sender authentication, that okay, it should be Alice and not Trudy giving a prank to him, and message should be integrity should be there. Okay, so it should not be modified. So what does Alice do now? She reads the Koros book again, and she says that now she finds the hash of the message. Okay, this hash is a kind of fingerprint of this message. See, she now encrypts it with her private key. Okay, so if she is encrypting with her private key, so then it tells that okay, it cannot be. So this is done. Okay, let's first see. So Ka minus C, she encrypts this H of M, and she also sends the message. So Bob receives M and Ka minus H of M. This was the private key of Alice. Okay, so Alice has this private key, and only now what Bob does, Bob decrypts with public key of Alice. So he applies Ka plus to Ka minus H of M. So he will get, now because he decrypts with the public key of Alice, he will get H of M, and he also got the message. So he now finds the hash of message. If this hash and hash of this one are same, so message and the hash of message obtained here both are same, it means the message has not been modified. Okay, and how is it known that okay, it is Alice only who has sent? Because it is the property of the private key. Okay, so Ka minus Alice, whatever H of M she had sent. Okay, so when you apply the public key to this and you get HM, and here also you are getting HM, then there can be nobody else, because nobody else is knowing the private key of Alice. So that's why Alice only is sending this message, because no one else has got the private key of Alice, and he was using the public key of Alice and finds that messages are same. Okay, so this provides a sender authentication. Message integrity, why? Because if this M was changed to M dash, then what happens? And here Alice had also sent H of M. So now if this H of M, and if we find H of M dash, then if they don't match, then it means the message was modified. But because HM and this M dash, H of M dash are matching, it means the message has also not been changed. The last one Now Bob thinks that okay, he's becoming obsessive about Alice. He wants secrecy to no one else, none of his friends should read that message. So he wants now secrecy too. So Alice now goes and reads Kuro's book again, and in the next few pages she finds a more difficult algorithm. So now she needs to provide secrecy, sender authentication, message integrity, all of these. So first, to provide integrity of message, she finds H of M, okay, a message digest she finds, okay, then she applies Ka minus, she signs it with her private key, which will authenticate that okay, she is the only one who has signed the message. So H of M, she signs this message. Now she encrypts it with her the secret key shared among them. Okay, so she applies K minus H of M. So now this is the secret key encrypted, which is shared, so symmetric key. But this symmetric key is now not known to Bob, so she also adds the key, she encrypts it with the public key of Bob, and only Bob can decrypt the KS. So when Bobs receive all this, he first decrypts the symmetric key, shared symmetric key, so he will apply KB minus to KB plus KS, and now only he can decrypt and find this KS because he has only got the private key. So he finds KS. Now he applies the symmetric key to this message KS, and he gets Ka minus H of M. Now what he does, so he applies the public key of Alice, okay, and he will get H of M from here, and this message was also sent along with this and this. So now he finds H of M, the message he got, and if both of these are equal, this means message integrity was maintained. And if he got, so KS, he got the shared secret key, and because the HM and this was same, it means that message was authentic also, it was sent from Alice. So this is how he ensures all the three: secrecy, confidentiality, sender authentication, and message integrity. So I hope you enjoyed it. Thanks a lot.